Thank you for joining in today's webinar, Improving Patient Outcomes at Children's Hospital of Philadelphia with IBM Advanced Analytics. My name is Brad Peterson. I'm with Technology Dynamics, and I'm pleased to have Bill Neatspiel, the Senior Director of Enterprise Analytics from Children's Hospital of Philadelphia, join us and speak to you today. So we will be recording this session, and we'll make it available following the afternoon. If you do have any questions, please feel free to use the question section or the chat section. We'll do our best to monitor and answer throughout the presentation. And if we don't get to your questions, don't worry. Someone from my team will be following up after the event and make sure you have everything answered. So a little bit about TechD. This is the team. You may have met or spoken to some or all of us. Mark Martinez, our Senior System Architect and Managing Partner. Jenny Happus, our Director of Operations. Craig McGinn, Senior Consultant and Managing Partner. And myself, Director of Business Development. Any of us are available to speak to you. I'll provide the contact information after the event, and we look forward to working with you. A little bit about TechD. We're a certified IBM Gold Business Partner. Been in business for about 10 years, located in the Philadelphia area. We specialize in all things data, really the life cycle of data, from collection and ingestion to data quality and integration, making sure that not only the data you capture is in the right place, but that it's clean and valuable to your organization. And they're really bringing it through to extend to your business, so you can make better decisions with business analytics, Cognos analytics, planning analytics, and some of the portfolio that IBM has to offer. So we build our solutions on IBM Analytics software, and we are happy to have you here today. Also, after this webinar, we do have a couple other events coming up here. We do a number of workshops. We have one more scheduled for June in McLean, Virginia, and we'll be covering Cognos Analytics as well as Big Data Analytics, healthcare organizations. We also have two upcoming webinars. On June 12th, the latest version of Cognos Analytics R11, as well as June 21st, the latest latest edition of IBM Planning Analytics. We'll be demonstrating the new capabilities and features on that webinar. You can visit us at our website, as well as contact us directly at the email address provided, and we'll be happy to discuss more and fill you in on any other upcoming events you might be interested in. So with that, thank you again for joining. I'm going to turn the presentation over to Bill Neatspiel, Children's Hospital of Philadelphia, and Bill's going to take us through today's session.
Good afternoon, everyone. My name is Bill Neatspiel, and I am the Senior Director from Children's Hospital of Philadelphia. First, I wanted to go over and show you just some stats of who we are, and just in case you didn't already hear of us. We are a 561 pediatric inpatient beds. We have about 30,000 inpatient admissions a year, and we see over 1.2 million outpatients encounters every year. And we have over 50 care network locations, and our main focus has been on patient care, of course, research and education. So what I wanted to do is actually just go over an overview of our journey with big data and analytics. That started roughly about 4.5 years ago, that we've been working with for the IBM platform. But as you'll see as we go through the slide deck, that we've actually been working on this for quite some time. So overview of what I'm going to cover today. So first, I'm going to go over analytics governance, our roadmap and strategy that we've been working from, our architecture for big data and analytics, an example of real-time data streaming that we have implemented from our medical devices, our vital monitors and ventilators. Also, some of that from our EHR, where we're pulling over our HL7 ADT messages. how we're storing those real-time streams, and actually just a quick use case of how we're in the process of taking that data, analyzing it, and putting together some analytical functions for the data in flight. So first, around our roadmap and governance structures, what we've been doing is we've actually implemented a 3-tier governance structure for our organization, where we have essentially an executive where we're a group where we're deciding the strategy and putting everything together at that very top level, so the top-down approach. Our execution level, which is essentially the collection of all the leaders for a lot of the analytical teams that we have spread throughout our organization. And then the delivery groups, which is essentially all those teams individually together, and how we're progressing with analytics as a whole. The 3-tier governance, from a graphical point of view, this is what we kind of have set up right now. Our executive group is the Enterprise Data and Analytics Steering Committee that consists of all of our C-level executive leaders. As we step down into our execution level, we have essentially 2 groups. One is our Data Governance Committee, and the one also have an Analytics Operations Committee. And those committees have delivery groups that kind of report up through them from a status point of view of kind of giving direction of where things are at and setting the priorities for the organization within those specific areas. From a roadmap, what we have been doing as we started our journey, and this was, when I started here, it was 9.5 years ago, we were squarely in the retrospective analysis area of the business intelligence, where all we were doing is reports out of our system and not really doing very much with that. Very, very, I would say, basic reporting is what was occurring at that time. As we started implementing analytics here and kind of set our roadmap up, we started moving further to the right of the screen, which is going from just reports. We started creating dashboards and scorecards, benchmarking, moving over to our explanatory phases, where we start doing more profiling of our data and classification of the data, of trying to look at, why are things happening? And now we're at the level where we're starting to do a little bit more predictive analytics. We have a lot more statistical models and predictive models that we have created, measuring the effectiveness and starting to go towards more risk scoring and having that actually become implemented as part of the work streams that we have implemented at this point in time. The way we use this roadmap is that we always look back on it and try to figure out how we can start moving forward and getting to that more of that nirvana spot, being a prescriptive analytics where the data is actually being utilized from a day-to-day decision support point of view. So advanced analytics, what I wanted to do here is just kind of give an explanation of what it means to us, especially because a lot of the terminology gets thrown around a lot. From our point of view, it's integrating a lot of our medical devices and bringing over all that streaming information, implementation of natural language processing, text extraction, working through risk scoring algorithms, and essentially applying that right in real-time analytics alerts. And what we do is we utilize a large amount of technology to essentially get to this point. So what I wanted to do next is go over our big data tools and architecture. So our current analytics tool sets that we have implemented in our production environment are, we utilize Epic as our EMR. So we have some of the tools that Epic provides native with their platform. We are an IBM Netezza customer. We have been using that for over 4.5 years. We do use business objects for both the Crystal reports and also the web intelligence for self-service reporting. ClickView is our main tool that we're using for dashboarding and more of our guided analytics. We have a plethora of people that are using Excel out there, so it's always good to represent that. Analysis services, we have some of the cubes that Epic provides, so we have that platform set up as well. And a couple of the other things that are more towards the advanced analytical space is that we are using IBM Streams for our pipeline to apply algorithms in stream. Spark, Hadoop, and R. We have all three of those running. And from a geospatial point of view, we're using Esri, and for NLP, we're using Health Fidelity as our processor. So our architecture is this diagram I've used in the past to kind of just show how a lot of things are occurring at one time. And there's in the center of the diagram here, we'll show what our warehouse represents, which has it's essentially a combination of two pieces. One is our Netezza platform, and the other one is our Hadoop platform that we have working in conjunction with each other. And across the top is our streams processing engine through IBM streams that we have as data is flowing from all the various data sources on the left, moving over to the right where everything becomes more actionable as we go forward here. So it's just some stats about what we're working on or what we've had in our warehouse. Just to give a little bit of a reference point, we have over 10 million patient records, and our patient record and it comes from our legacy system that we had prior to Epic, and also what we have currently in Epic. We're running through 82 million encounters. We have our employee information also in our data warehouse. We're running through approximately 44, and I put the plus data sources because every day that we move forward here, we're always adding new data sources. And our data sources are from a variety of locations, mostly from the ground. We have a few cloud that's growing every day, and also sources that are real time. We have over 9 terabytes in data stored right now, and over 87 billion rows of raw data. And just to give a quick glance of some of our data sources, we are an Epic shop, as I mentioned before. We use Lawson as our ERP system, and GE is our primary device manufacturer. And then from there, there's varying levels of sources that we go after. Some of these we're probably familiar, especially if you're within healthcare, as a lot of these are very industry standard. So our general data flow that we have, traditional nature, we utilize Informatica as our ETL tool. So from all of our sources that we have, both cloud and ground, we do utilize Informatica. So Lawson and Epic are our primary ones. We move that data through our CHOP data warehouse, and then essentially use the data warehouse as a source of truth for analytics for all of our tools that connect up to our asset. Our Informatica implementation is Power Center. We're using that for essentially through our SDLC process, so our development, user acceptance, and production. We have separate environments for all that, and we do use our Informatica tool to populate those environments accordingly, because our source is typically for more productions. We have to do our development cycles in those other areas. We're processing approximately 1 billion rows a night in data, and we're loading everything daily from more of a batch-oriented, except for our real-time sources, into our data warehouse. And right now we're running about a 3-hour execution time to load all of that data in to our environment. From a support point of view, we do have on-call, overnight on-call support from my team, just to best support anything that happens. So we're constantly moving forward, and any kind of hiccups that happen, we address them right away without impacting the next day's worth of work. We spend an extensive amount of time validating our data warehouse. One of the things that is very important for us is that we have accurate information. One thing that we haven't, that we won't allow for, or things that we're very cautious of, is to make sure that everything is accurate in the system. Anything that happens upstream, we're quick to react and make sure that either communications go out while that data is being corrected upstream, or also that we will work to try to correct as the upstream systems are being corrected themselves. And this has to do a lot with the integrity that we have for the system, because as anyone who's has experience working with data warehousing or working with a data management team is that your reputation is as good as the data that you have in your systems. One thing we also do work on is that we're constantly doing quality checks and sign-offs pre and post our production migrations. So not only are we running validation routines as we're in our production environment, but anytime that we run forward or we go to move forward with moving new data sources into our environment, not only are we doing our due diligence checks, but we're also getting sign-off from the data owners in those respective groups to make sure that the data is matching not only just to the system, but also to what the governed items are, meaning that if we're looking at a definition for something, so let's say something simple as length of stay, that the data owner for length of stay through our data governance organization also agrees that what we're showing and putting or if through our data warehouse matches what the enterprise standard and definition of that is. So what we have is here is I wanted to go over some of the performance stats of what we had when we went up onto our IBM Netezza platform. And prior to moving to Netezza, we were an Oracle shop. So we had our exact chop data warehouse that we have right now from a data model point of view. We just migrated that from Oracle to Netezza. And the primary reason that we went down this path, as I said 4.5 years ago, was that we were noticing a lot of performance issues with our Oracle platform. So after we went through a POC and implemented that, we noticed our data loading speeds are anywhere from 2 to 10 times faster, and the querying speeds, depending on the complexity of what we were going after, was anywhere from 2 to 2,000 times faster. And interestingly enough, the more complex the query, the faster it would run on the Netezza platform versus the Oracle platform. So a lot of the times the 2x query that we have listed here was the very simple, like just select something from a single table. It was, not very much different between the two platforms. But as we started implementing multiple joins and more analytical functions, that's where we started creeping up to the 100 to 200 to 2,000 times faster. So also in our environment, we have over 900 terabytes available, and that's a combination of our advanced analytics database through Netezza, which is 96 terabyte, and also our Hadoop cluster, which we're running at around almost 900 terabyte. So I'll talk about our streams architecture. So a project that we were working on that's starting out of our anesthesia department was to actually start bringing over real-time parametric data from our monitors. And it was actually both the GE monitors and also the ventilators that existed in our NICU and ORs that we had available to us. So with that, what we did is we were looking for a solution to actually bring over that information in real time so we can actually apply an algorithm that we were working on to detect if a patient was intubated properly or not. So the way that we worked through this was we looked at all of our devices and started streaming that data over. At the same time, since the devices didn't actually have the patient information in there, we started streaming over all of our ADT events from Epic. And through our streams platform, we were able to bring that data together, which is what they're calling the ingest phase, enrich and evaluate, which we actually pull data that is from Epic that we have from Netezza here, which is device mapping, and then send out all of our egress and alerts to our big insights platform that we have, storing all the data that's coming out of those monitors. And roughly the monitors are running, are sending data at a 6-second interval. Some of the ventilators are a little bit longer than that, but it's very high frequency data that we have streaming into those environments at this point in time. And this is just a little bit more of our how we're actually running through the integration itself. We are using a vendor in Nuvan. I think they're called Bernoulli now, to actually timestamp and synchronize the devices, because one of the challenges when you're doing streaming and device integration is you have hundreds of devices out there that all can have timestamps that are off by a little bit. So if we run them through a single gateway, then the timestamp issues we can be resolved from that point. So some of the other parts of our integration just is what we do is we look at the streaming data as we're pulling it over, and there's a lot of technology that's involved in that and the capturing and storing and the process of that data. And then when we look at some of the areas that we actually start applying some science, there is, and that's the center section that I have listed here, which is the data processing area. We have there's some data and technology, there's a lot of data science, and there's also subject matter expertise that has to interpret that information that's actually being processed. So we can actually apply some of these alerts and also automated decision making to get to our desired output, which for the use case I was referring to is just a risk score of the intubation actually occurring properly. So some of the things that are it's very important from the streams point of view is that we are built-in analytic capabilities built into the streams product, where you can actually take your models that you develop, be it in whatever platform is something that you're using within your environment. For us, it's R, and we were using some MATLAB as well. We can implement that in stream using the IBM product. And then also at the same time, as you're using and analyzing your stream, you can send that information to any kind of location that you have deemed. So for us, it was we're dumping our data to HDFS to be utilized later, as well as running algorithms against it as it was going through the pipe. The one of the part of the streams is that it's a very open architecture. So like I said before, you can integrate it with whatever you might have at your location. And it has a very robust and integrated development environment to be able to use the streams platform itself. So if you're familiar with Java, you can utilize that. C++ or C, then you can actually use those languages as well. And that kind of wraps up a very quick, high-level version of what we have implemented here at the Children's Hospital of Philadelphia. And as I was saying before, the use case we were using streams for was to run through our intubated anesthesia patients to make sure that the intubation was done properly. So I think now we'll open it up for questions. And Brad, I'll turn it back over to you right now.
There we go. Thanks, Bill. Thank you for covering the solution. And forgot to mention in the beginning, TechD has been really appreciative of the work you've done and the opportunity to work with you guys and the team, and to continue to do so. So thank you. Unmute the lines here and feel free to ask a question. Let me. Apologize, having trouble with the connection here. If anybody does have a question, if you want to click the raise your hand button, I'll should be able to unmute you directly, or you can use your audio pin when you dialed in, and that will open up your line. Looks like we have a question from Kevin Rapier. Kevin, your line is open.
Hi, thanks. I joined a little bit late, so I was wondering if you had any examples of what was the final output of the streams process. You said it was so you could track to make sure intubated patients were being done properly or something like that. I guess I kind of missed the punchline of the whole thing. So was that one of the earlier slides or?
No, I didn't actually have the results of that because I didn't know if that was appropriate for this webinar or not, but I have. So what we did with that is through our research, we have an algorithm that is built, and we're in the process of implementing that with our anesthesia group right now. So I don't have the results in terms of their production implementation of that, but from a model point of view, we were somewhere around the 75% area of detecting a proper intubation or not. We are, like I said, in the process of implementing that with our anesthesia group to make sure that we have this done properly. We've had a little couple changes in leadership, so that's kind of been part of the delay, but we were ready to move forward from a technology point of view to do the implementation of this.
Okay, thank you. I'd just like to see how that circle gets completed. I'm very interested in that.
Okay, thank you, Kevin. Anybody else has a question? Please raise your hand. Okay, great. Well, I think that's all we have for Q&A right now. Again, thank you everybody for attending the session today. If you do have any questions that weren't answered or would like to discuss further, one of us will be in touch to follow up. Would appreciate your time and hope you have a great afternoon. Thanks again.